Hey guys, let's analyze the Atwood machine today. So an Atwood machine is a pulley with two masses connected through a string, a massless string. Okay. So we'll again assume that the pulley is massless and the string is massless. Their mass is negligible. And again, the reason we assume these is that if the string has mass, then we have to consider the mass of the string, mass of these portions of the string, right? And uh, if the pulley is massive, then we have to include the moment of inertia, and we have to bring in the concept of torque, which we'll do later. So we'll analyze a simple system right now, in which these two are massive, and the string and the pulley is massless. So let's call this guy again M1 and this M2, and we'll assume that M1 is greater than M2. Let's assume that M1 is 7 kilograms and M2 is 3 kilograms. Okay. So let's first draw the free body diagrams of these masses. So of course there's tension in the string, and there's tension in the string over here. And since M1 is excuse me, since M1 is more massive, then of course the system will move in this direction, right? And this guy will move downward with the acceleration a, and this will move upward with the same acceleration. Again, the constraint is the same as before, as we've discussed for the two masses connected through a pulley, one on the table. In that case also, the acceleration was the same. In this case also, the acceleration of the two masses is the same, because again, if this guy moves down 1 centimeters, this guy moves up 1 centimeters in the same time. So if the string is not extensible, it's not like a rubber band, then their acceleration is exactly the same. So let's draw the free body diagram of this mass M1 first. So M1, for M1 the free body diagram is again their vertical forces only. So for M1 there is tension the upward direction and W1 in the downward direction. For M2 we have, now for this guy acceleration is downward, and that's your acceleration, and for this guy again tension up and W2 down. Okay, so acceleration for this guy is upward. Now let's write Newton's second law. So we get W1 minus T equals M1A. So F net equals mass times acceleration. Make sure you have mass M1 over here, and this guy's moving up, so tension is greater than W2, so you get that T minus W2 equals M2A. Okay, so let's call this equation 1 and this equation 2. Okay, so let's add 1 and 2, or you can take tension from here and plug it in over here. Again, we are trying to get rid of tension so that we can get our acceleration in terms of the masses, and the value g equals 9.8 meters per second squared. So so let's add 1 and 2. We get W1 minus W2 equals M1 plus M2 times A. So acceleration turns out to be W1 minus W2 divided by M1 plus M2, which is just M1 minus M2 divided by M1 plus M2 times G. Okay. So this is the acceleration of this system, and since we assumed some numbers over here, so you get, so M1 minus M2 is, so 7 minus 3 is 4 kilograms, and 7 plus 3 is 10 kilograms. Let's say that G is 10. Right? I like to assume that sometimes that's 10 because it makes the calculations easier. So you get So you get the 10 of course cancels out, so you just get 4 meters per second squared. So that's the acceleration of the system. Okay. So so tension, you can also find tension if you like. Tension is so you can use this equation if you want. Tension is W1 minus M1A, so you get M1G minus M1A, so M1 times G minus A. So M1 is 7 kilograms, so 7 times 10 minus A is 4 newtons, so you get 7 times 6 newtons, so 42 newtons. So that's your tension of the system. Okay, so so that was Atwood's machine. This is you should write this down, Atwood machine. Again, a very common question in introductory physics. So hope you like the video. Please subscribe, and if you have any questions, post them in the comments. Thank you for listening.